Hi Spiros, my name is Sydney. I have some questions for you and thanks for coming to hang out with us. I'm like super excited about it. I drew the x-axis, which is the skylines, and the y-axis is vertical or going forward. And we've been talking about going forward, but not really the vertical skylines. Where we were at the Salton Sea, we were easily able to see skylines about 10 to 11 miles long or longer, going left to right. The buildings never went and leaned away from each other, and at that distance, it should be like a 70-foot lean, and the Tower of Pisa only leans 15 feet, and we can see that with our eyes, but we were unable to see a 70-foot or greater lean. There are other buildings which lean very few feet and we can see it with our eyes. Plus, when we go up in airplanes, we get these 200, 100, 300, maybe more mile skylines, and we never ever see Earth curving down. If you put a paper up to the airplane window, it's just flat. So I think what you were saying, the answer to that is that Earth is kind of sitting in a space-time warp. So I guess the space-time warp would be like here, and it would be pushing everything up. So it would make the curve, which should go down, kind of push up and sort of look flat to us. I think that's what you were trying to say. And then therefore, this pushing upness would allow us to also see across the y-axis. My question on that is, Earth is a sphere. So are you saying that that we're embedded in a flat plane and there's only one force of space-time bending? Because as far as I understand from space, a sphere would be affected on all sides the same way by space. So that would mean that there would also be this same warp like over here, and Earth would also be bending space-time this direction. So this one and this one should cancel out and be equal, and then we're back to a sphere. So we shouldn't be seeing the flat plane, we should just be seeing it how it is. That's my question to you also. If the forces can be unequal and only on one side, then why is it that on the other side of the globe, does it not look like this to us when we're standing on the edge of the globe? And then in that case, it would be pushing this way, and your horizon would look like, it would be really like warped, because the space-time would be bending the horizon. Why is it that if once it's on one side, do we not see warpage? But I don't think it can be like that, because as far as I understand from space and spheres, all the pressures should be equal. So I'm just wondering what you had to say about that. My second question was about the gyro that you said measured movement of the Earth about 15 degrees or something like that. And I'm trying to figure out why, if I am relative to the Earth, I am motionless and I can't feel any motion, then how could the gyroscope, which is also relative to Earth and should be motionless relative to Earth, feel motion? And why would the gyroscope get motion feelings, but I wouldn't? I'm confused. And as Wendell had mentioned, it might be possible that the gyro is measuring the movement of the stars rotating above us, if somehow it can just measure all kinds of movement. So I wondered what you thought about that. My third question is if you think that gravity has to be an equal and opposite force to the vacuum of space and centrifugal force in order to keep air on Earth, or can the forces be imbalanced because centrifugal force lessens as you go up towards the North Pole and would be moot point up at the North Pole. So it's not an equal and opposite force to gravity. So doesn't that mean that the air would then, the gravity would not be an equal and opposite force to the forces that are trying to pull the air off Earth? So wouldn't everything just fly off of Earth? And then the fourth thing is, if you could take a look at this picture, it was from one of our experiments at Monterey Bay. And we shot me and Wendell on flashing a mirror at the water level. We have the video coming soon. This is just a snapshot off of the video. And if you zoom in on the flash from 14 miles away, which should have been like
80 feet under the curve, or with refraction, like 60 feet under the curve. I'm sure Nathan is going to show this to you, but you can actually zoom in on it and you can actually see the actual rectangle of the mirror, which means that we're looking directly at the source. You can see the edges are straight and everything, little flashes coming off the top right hand side. So I'm looking right at the source here from 14 miles away. This is supposed to be underneath the curve of a 6 to 7 story building. So I wondered what you had to say about that. Thanks, Spiros. I just had a last question for anyone watching this video, is why do science people get so angry and disdainful about flat earthers? I just don't understand why they get so angry. Urgh.